So thank you for coming to my talk today. This is a developer's field guide to software security, a step-by-step guide on how to get started. I'm Janesko. Oof, I should probably actually click over here. I'm Janesko. I'm old. So I've been working in IT for a little over 20 years. I moved over from programming and managing into security about 6 years ago. And so I started out as a Cold Fusion programmer. I don't know if anybody on the call knows what Cold Fusion is. And then I moved into Java, PHP, C, so on and so forth. But Java is where I spent most of my time. Then I went into management, and I did IT integration and management of things. And then I had the opportunity to take this security class. Actually, it was cryptography, applied crypto. And it was magic for me. And I was like, I have to get into security. So that's where I'm at today. I'm a security consultant. I've worked with all kinds of companies for the past 6 years in all walks of life, from regular application development all the way through industrial control systems. And so security is really exciting to me. And I also have a soft spot for software developers and software engineers. So my last big project, I've been working on software security. So a little bit about you. If you're watching this talk and you are very skilled in the area of software security, this is probably not a talk for you. This talk is geared towards people who are looking to explore what are the options within the area of software security. How can you get started? So if you're very experienced, you might be a little bit bored in this talk, although you might gain some tips and tricks maybe along the way. But I don't want to waste your time at the end of a Friday before weekend. In Germany, we have this thing called Feierabend, which it's a word, and it actually means celebrate the evening, which it's the end of the day, so let's go celebrate the evening. So if you are super experienced, go have Feierabend because it's Friday and it's weekend. If not, and you're interested in staying around, I'm happy to have you on board. Full disclosure, I work for Synopsys. We are a software security company. I work in, so there are like 4 rows here. I'm in the security consulting part. I help with software security in different firms. I'm not going to be representing so much my company today. I'm going to be talking about software security in general. And so I'm going to tell you a little bit about the origin story of this presentation. So they asked me to make this presentation and they said, you need to talk about software security to software engineers. And I thought, okay, how do I go about doing this? And I recently read The State of DevOps. So if you haven't read this report, it's a super interesting report put out by Dora and Google Cloud. And it looked at like 31,000 different software or actually DevOps engineers across the world, and looked at practices in different DevOps shops to see what does a good shop look like, or not a bad shop, but a less mature shop look like, and what are the practices that they saw in common across the board. And so to me, that was a super insightful report, especially with the software security work that I do at the customer. So that has been super forming for me. The next thing that I will probably highlight a lot in this talk is a study called the BSIM. And the BSIM looks at software security practices across companies. And so we've looked at 122 different companies and what their software security practices are there. And we look to see what practices are common, what are less common, what work, what don't work. And so I'll be referencing that, and that influences me greatly when I'm working with my customers. And then the last but not least part of the origin story of this presentation is I have hands-on experience. Like, I've been on the ground with software engineers trying to do software security with them, and I've seen some things and I've heard some things. And so I'm bringing my own anecdotal information or experience to this presentation as well, because I think the state of DevOps and BSIM, it doesn't tell the whole story. So without further ado, then, that's where this presentation is coming from, or what it's heavily influenced by. And so let's get started. Here's my bold agenda. First, I'm going to talk about the problem. Then I'm going to give you the field guide. And then after that, I'm going to give you some practical tips for software, or actually for the field guide. And so here's the problem. Software gets published, or it gets pushed to production or deployed to production, and it often is not checked for security problems. So in this picture, we see this nice arc. On the very left-hand side, we have our software engineer who's committed some code to the repository with an XSS or cross-site scripting vulnerability. Because there's a lot of pressure to deploy, because you want to get this business feature out, the penetration test that was scheduled for this software was skipped. So it goes to production. So we have a big shiny star because yay, we got to production on time, super duper. Once that software has been pushed to production, then an adversary or an attacker notices that there's a cross-site scripting weakness. That's super exciting for an attacker. And so the attacker takes advantage of that weakness. And actually occurs quite a lot. And the incident response people don't notice this until people start complaining in Twitter. I see so many complaints in Twitter about defects, security defects in the world. It's a great place to look if you're in incident response for security problems in your own software, in your own production software. So the incident response people get wind of this and look into it and realize, oh crap, we have a serious problem. And so they start the whole incident response process. They break out the run books, they contact the right application groups, and they work on the problem until it's solved. And so that means that the weekends, the evenings, everybody's involved, they get the problem fixed, and then things go back to normal. In the meantime, some regulatory agency has caught wind that there's been a problem, and that Acme, our company that has pushed this bad code to production, they're no longer in compliance, which has implications. So if you think about the cost of a software breach, it's not just the incident response time. That is the cost. You have the cost of the incident response team who actually has to work on the problem. You have the cost of the DevOps engineers who actually need to investigate what is the problem, where is the problem, is it in the front end? Is it in the microservice? Is it in the API? Is it in the database? Is it in the different levels? Where is it? Then once they've identified the problem, they have to fix the problem. All the time, that's taking away, or it's creating security debt. So it's taking away from your ability to develop a new feature. And so you're falling behind on your features. You are focusing on getting this problem solved. There's also the management cost, where the management is focused on, okay, do we leave this application in production or do we take it down? And then they're busy focusing on this problem, and they're not focusing on other things that they could be doing to bring the company further. You also have legal costs. Legal sometimes has to get involved because you have end users who could be potentially impacted. Then you have your social impacts. So there's the reputation of the company that you have to worry about. The reputation of the actual team, who is the root cause of the problem. So the team that forgot or missed the cross-site scripting vulnerability gets kind of a bad reputation, and they're not so, they're not in a good light on the management side. And then the morale of the product team that actually caused, or that was the root cause of the problem, also morale goes down because you've lost feature time, you worked over the weekend and you're tired, and you had a really bad bug that caused your customers some serious problems. And then there are the monetary impacts. So there could be compliance fines depending on what the compliance issue is. If it's a PCI DSS issue, you're going to pay money. GDPR, possibly pay money. So there could be impacts there. Also, in certain cases, if the impact is bad enough to the end users, they could sue, and that ends up costing money as well. So the cost of a software breach is quite large. There was a recent IBM study that put the average cost of the software breach in the millions of dollars, which, and you're taking into consideration all of these cost factors. So you want to avoid software breaches in any case. So we're going to revise what we just did, this timeline, and we're going to focus on, rather than not pushing the code to production, we're going to go through that penetration test. And so this revised timeline has the cross-site scripting vulnerability was committed to the code base. Then the penetration test is run, and the penetration testers catch the vulnerability. Now, the penetration test lasts for at least a week, because that's how penetration tests go. You get the results at the end of that week. Oh, cross-site scripting vulnerability. You go and fix the cross-site scripting vulnerability. Maybe there's a penetration test retest or not, but you fix the vulnerability, and then you reduce, or you deploy to production. Okay, well, that's not a super agile way of doing things. And because you had the penetration test and the lag, your push to deployment was late. The adversary, the same one from before, looks for vulnerabilities in your code, doesn't find any. That's a good thing. Some customers have picked up and are tweeting about the success of the product. Your incident response team gets a quiet weekend. But your competitor, so Acme's competitor, got their feature out first because your feature was late, and Acme loses market share. So in this scenario, we have a couple of not so nice things. We have some good things. We got rid of that cross-site scripting vulnerability and all of the cost associated with breach. But our push to production was late because of the penetration test. And for that, we lost market share. Now, I'm not saying that penetration testing is bad. I think penetration testing is awesome. It does some things that that no other type of automated scanning will do for you. And I recommend that if you have a critical piece of software sitting in production that you've developed, that you have a penetration test. And it doesn't have to be necessarily within the development, the whole development cycle, but at some point it needs to be a penetration test to make sure that the logic flow and some of the more complicated attacks can be covered. But the moral of the story is the penetration tests, push things off too hard or too late. So what if we revise the timeline again? And in this case, somehow our software engineer has figured out how to resolve that cross-site scripting vulnerability before checking it into code. So at some out-of-band time, the penetration testers test the application and they find no cross-site scripting vulnerability. But the resolution of the cross-site scripting vulnerability is not dependent on those penetration testers. So you push the code to deployment just in time because you fixed the problem yourself. You didn't have to go through penetration testing. The adversary searches for vulnerabilities, finds none. Awesome. Lots of customers have picked up on the feature or using it and the product associated with it. And they're like tweeting, yay, this is an amazing product. And then Acme beats their competitors and gains market share. So that's the dream, right? Getting the features to market on time so that products can be sold and company makes market share. So how do we get from software engineer that accidentally checks in vulnerable code to super software engineer who can take care of those vulnerabilities on his or her own or on their own? So that's what we're going to talk about now. Here's the field guide. So, need to loosen up. We're about to do some things. So my field guide is broken up into 3 different parts. First, language lessons. Second, trust your tools. And third, find your allies. And so let's get started with language. This will probably be the hardest part of your journey into software security. And that's actually speaking the language of security. So I have been in the security ivory tower for more than 6 years. So I actually did a master's in information security. And when I first started, I remember my head exploded when I had to learn all of this new terminology and a new way of speaking. And actually, it's information security in general has its own language, and even software security has its own language. But what's cool is that there's a very nice group out in the world called OWASP that can help you learn the language. So this is the Open Web something, something, something group. They've been around since like 2003, and they've been doing software security since then. And they have 4 guides that are super great. And I have them listed here in the slides, and I can put out the slides later because there are a lot of helpful links in the slides. The first link is to the OWASP Top 10 for web applications. And OWASP is this organization that does software security. It's completely open source. And they publish top 10 guides. And what they do is within the areas of web, mobile, APIs, and also IoT, they publish these top 10 guides. And what the top 10 guides do is they look at the market for like the past couple of years, and they see what are the most common vulnerabilities that show up in the world. And then they put them into these top 10 guides and rank them for you. So that you know, okay, what are the most attacked things in the world right now? And they update their guides every 2 to 3 years. So they're usually pretty fresh. And so if you go into their guides, you're going to learn, you're going to get examples of different kinds of vulnerabilities. You're going to learn the vocabulary that goes along with these kinds of vulnerabilities. Sometimes they even point you to places where you can go for code fixes for these kinds of vulnerabilities. So it's a very powerful organization. And most scanning tools, or most security tools that you use for software, their language goes back to OWASP. So when a vulnerability is reported, it's often reported in OWASP terms. So if you are familiar with what OWASP has to offer, then you're going to have a lot easier time working with tools later on. But I'll tell you what, reading guides are kind of boring. So somehow you want to get really fast into what the language is. So you could, I'm going to give you a couple of ideas of where you could get information more quickly and more effectively. And the first is seek out your security ninjas in your software security group in your work. You're thinking, do I even have a software security group? Or man, the people in the software security group, they're always so crabby. Or, I don't know, software security group, where do I look for that? A lot of times, organizations will have software security groups, and it's manned by people who are usually first trained in security, and then they grow into understanding more software security and how to integrate with actual software engineers in the organization. They will likely have resources for you. They will have videos, they will have organized ways of getting into software security. Go and talk to them and figure out what they have for you. They would be overjoyed to hear from you. You may get more than you actually need. They love security. They want to make things more secure, and they'd be very, very excited to have somebody else on the software engineering side who also has that same interest. But maybe you don't want to talk to them, which I completely understand. Security people can be a little bit overwhelming. I know this. So my next suggestion would be go and look and see what you have online at work. Do they have a Confluence page where they list different resources for you? They've probably already curated the resources. They're probably just sitting there waiting to be clicked. Somebody has made some special list for the software engineer who's interested in security. Go look for it, click through their links, see what it has to say, because it's going to save you time when you are learning the language. The next option that you have is to actually look at your internal professional development platforms. So do you have Linux Academy? Do you have Pluralsight, Coursera? All of these different platforms have different versions of the OWASP Top 10 training in them. There's a lot of videos. Sometimes they actually give you exercises that you have to do. So just do it. This is why they're there. A lot of times they're for free, or the company pays for them and you can access them for free. Take advantage of these resources because, yeah, it's going to expedite your ability to speak security. And if those three things fail you, you can always go do your own online searching. So here are some external resources that I have actually gone through and picked out. All of those resources that I just showed on the page before often have either free or low-cost versions for you to actually access the resources there as well. So you might look into that. OWASP, as I mentioned on the very first slide in the language section, has some very good pages that describe the OWASP top 10 and the different vulnerabilities. A very cool resource is the Portswigger Web Security Academy. It's free, you sign up, and then they teach you about different kinds of vulnerabilities and give you the opportunity to do the exploitation yourself. And it's all contained in their online academy. I like to go in there every once in a while and brush up on some of the things that I'm not as strong in application security. But yeah, it's a super resource. If you want to, these two apps, the Dan Vulnerable Node app and the OWASP Juice Shop, are applications that you can install yourself. They're intentionally vulnerable so that you can practice exploitation of different kinds of vulnerabilities. What's cool about the Dan Vulnerable Node app is that they've actually ordered their pages in the order of the OWASP top 10. So it gives you vulnerability number 1, and then it describes it, gives some examples, then you can click in and actually go practice the exploiting the vulnerability within that actual web application. And so it's something that you host yourself. You don't have to sign up for any accounts. And so, yeah, you get to practice on your own offline if you want to. And the OWASP Juice Shop is a little more complicated. However, it's a very nice Node.js-based application. Okay. So once you learn some language, you need to start actually applying the language. So how do you get started actually doing software security? So not talking the talk, we want to walk the walk now. So speak security, now what? Code and architecture review, yes! So for code review, there's actually a couple of resources that I like. The OWASP code review guide, it's actually really huge, but it gives some nice tips on how to do secure code review. And the next link that I have is Code Review 101. This is, it sounds like a basic code review guide, but actually the tips that it has in there is very specific for application security or software security. And so it's a super short document that gives you some very practical guides on where to look when you're doing your first software security reviews. And you can go out and look for coding guides online. I've put just like 3 examples here. Don't necessarily look for the big, huge coding guides. They do exist. Oftentimes, little short blogs that give you security tips actually are enough. So get out there, find something that has maybe 9 or 10 different things, and then try them out. So you learn by doing, try things out, see what works, see what doesn't work, and then go from there. The last thing that I would suggest is actually looking at the OWASP cheat sheet series. So OWASP has this huge GitHub page, which has just a bunch of cheat sheets for different types of scenarios. If you want to have a tutorial on how to use JSON web tokens effectively and securely, they have a cheat sheet for it. You want something for API security, they have a cheat sheet for it. They have over 100 cheat sheets. Just go and see what they have and open them. And a lot of times they're super practical and you can use them to actually improve architecture and then also improve code. So some of the skeptics in the audience are probably saying, she promised me tools. And why are you talking to me about code review? And if you're asking that question, there are lots of tools to help you with security. I just wanted to put in the code review first, sort of to get the pain over with. And now we'll move into the code, or the tool part. If you look at the state of DevOps, if you're asking about tools, they have a statistic that highest performing engineers are 1.5 times more likely to have easy to use tools. So I wouldn't say that security tools are the easiest tools to use all the time. However, there is definitely tooling available for you. And if you can figure out a way to use it effectively and efficiently, that is going to improve your process. When you look at BSIM, so 85 out of the 122 interviewed organizations have some sort of security tooling in use. So it is a mark of a more mature organization where security tools are used in an effective in an effective way. So I'm about to go through a list of different kinds of tools with you. It's going to be kind of fast because we have limited time. But I hope that if you haven't been exposed to some of these, that you get to try them out because they can help you make your software more secure. So I have a picture of the DevOps 8 diagram up here. If your development process doesn't look like this, I apologize. I'm just using the standard, so sort of sideways 8 diagram. I know that not all development processes always look like this. But let's just start from this sideways 8. And we're going to look at some different kinds of tools. So at the very top, you see SCA. And actually, you see SCA in a bunch of different places, and I'll talk to you about that why. SCA is software composition analysis, and we'll talk more about that. Then there are security linters, unit tests, SAST, and DAST. So those are the different things that I'm going to cover with you. And you'll notice these tools are placed very specifically in different parts of the DevOps 8 cycle. And that's because it is in like the coding part where security and linters belong and the build part where unit tests belong, so on and so forth. And so what I've tried to do is put those tools as close to the different parts of the process as possible so that you can see where they fit. So the first tool is dynamic application security testing. And I've put this one first because it's furthest right in the development pipeline before production. And so dynamic application security testing is also known as DAST. And essentially what that is in order to be able to use this tool, your application needs to be running on a server somewhere. And this tool, this DAST tool, will actually simulate being an attacker. And the DAST tool will attack and do very common attacks on your software in an attempt to show what weaknesses there are in the software. And so one advantage to this is that you're going to see what the script kiddies see when they're out using their automated tools to find vulnerabilities in your application. So this is going to catch the script kiddie kinds of things, the easy things, the lowest hanging fruit, so that you can fix it right away. And this is really nice because script kiddies use automated scanners to look for vulnerabilities, but also more mature attackers also use these kinds of tools to find the latest zero-day kinds of things, 0 days that have just been dropped, in order to be able to automatically take advantage of those weaknesses in the application. So if you're using DAST against your application, you're going to be catching those things that are really easy to exploit. So the only The advantage, well, I've just talked about the advantage, but the disadvantage with this is that you actually have to have a running application in order for DAST to work. You can't just run it against a code base or a code build. It actually has to be running. And then the application has to be in a space that is accessible from this tool so that it can attack like a normal attacker. So at the bottom of this page, I've actually given 2 examples, and actually not really 2 examples. One is an example, and then the other is a list of scanners or DAST scanners. OWASP-ZAP, if you don't know OWASP-ZAP, it is the Z attack proxy. So I probably should have put Z attack proxy in all capitals, ZAP. But it's an open source tool, and you can actually use it, and it's really a powerful tool. But if you want to get your hands dirty with DAST testing, download ZAP and then run it against your application. It is really appropriate mostly for web applications and web front ends. Sometimes it is effective against APIs. You just have to test, but it's really geared for those types of software. But if you can use that and you can see the kinds of vulnerabilities come back, you're going to start to see, oh, OWASP language is popping up when it starts listing the vulnerabilities, but it's also just, it's a very cool tool to start to understand how DAST works. Aside from that, in this slide, I have linked to a list of scanners. So OWASP actually maintains a list of DAST scanners so that you can have an idea. Their list is super long, so you can get a good idea of what scanners are out there and what you can work with. The next type of scanning that you can do is static application security testing, or SAST. It's a lot to say. SAST usually comes at build time. And the reason why is this. So when you commit your code and then you go for a build, SAST will actually look into your code once it's built and try to follow the paths, the application paths, the logical application paths that the code is set up for you, or that the code is actually flowing through. And it's going to look for vulnerabilities by passing things from method to method or function to function. So it's going to follow through the function logic. It's super thorough, and that is actually the advantage of SAST. The disadvantage is that you have to wait for buildable code, and it can take a while. So if you're used to something running in a pipeline and you get impatient when in a pipeline it's running for more than 6 minutes, then maybe put SAST in a different pipeline. So maybe do it in a separate pipeline, a security pipeline, and don't break your build if it doesn't, if it times out. So SAST can last anywhere from like 1 minute to 1 hour, depending on the size of the code base and the way that you've configured your SAST tool in terms of the depth that you want it to go. So SAST is super powerful, but it does have the possibility of running a bit long. So keep that in mind. And once again, I've put, rather than listing tools, I've given a link to the OWASP list of SAST tools so that you can go and look. The next tool is, or scanning tool, is software composition analysis. And this is a tool that allows you to look for licensing issues in third-party components or third-party software. It also allows you to look for publicly disclosed vulnerabilities in third-party software. And what this does for you is, especially if you're doing mobile, the licensing part is super critical, because if you're including some software component that has a license that shouldn't be used because you're pushing this code out actually to these things, yeah, you might get in trouble if you have these, or you might be in non-compliance, or you might run into legal issues if you're pushing code that shouldn't be pushed out to those things because of licensing issues. So software composition analysis can help you find those licensing issues and fix them, also find vulnerabilities in the code that you didn't write. And then you have to make a decision, do I use this code base or not? And if so, how do I use it safely? So the advantage is you're actually aware of the weaknesses in your third-party components. The disadvantage is, and I should take a step back before I talk about disadvantage. You'll see in my picture, I have it in 3 different places in the DevOps diagram. I have it at the code part. There are some open source components that when you load like an NPM library, it will do the check right there for you and say, hey, this is a vulnerable thing. People don't even necessarily notice that they have it in their IDE when they're doing it. If it's telling you there's a critical vulnerability, you should think before you use that third-party library. If it's telling you that there's a critical vulnerability and you still want to use the library, you're going to have to figure out what that critical vulnerability is and see, does it actually impact my application? And should I be using it? Or what other protections should I employ so that nobody can exploit that vulnerability? It's used at the build point as well. So some tools actually run at build time and do a thorough in-depth search of the code, looking for the licensing and vulnerability issues. And then I would also recommend running it when the code is in operation. And the reason why is if you have a good software composition analysis tool, it will always be up to date with the latest vulnerabilities. And if you do have a component that is flagged for vulnerability, critical vulnerability, when it's in production, you need to think about, okay, what do I need to do about that? And that's the real disadvantage with SEA, is you will run into scenarios where you have to make a decision about your production software, where it's going to flag a critical vulnerability when it does a scan of your production code base. And it's going to be critical. It's going to be in a critical application. And you need to make a decision. Do we take it down? Do we leave it up? What compensating control can we put into place to protect the software? And so it's super good to have as a flag for these critical issues in production, but you have to be prepared to take action when you get the information. And like the other pages, under examples, we have the OWASP list. So OWASP also maintains a list of software composition analysis tools as well, both open source and proprietary. Okay, so now we're down to self-made unit tests. These actually can be run at testing time, build time, or code time. I put them in at code time because, yeah, I just wanted to push it closer to code. The earlier you can get feedback to your code, the better, because it's, yeah. It takes less time if you can see it in your IDE as opposed to pushing it to build and running tests and then getting that feedback. So I like having things as close to code as possible. So for these self-made unit tests, what is it? These are self-created tests that test for specific security conditions. And you can imagine 2 different things when I talk about unit tests. One, there may be some specific logic conditions in your code that wouldn't necessarily be caught by any other automated scanners that you want to somehow mock up in your unit testing. So it's very good for this. Once you write the unit test, it's always there. So you can continuously update your code base and expand your application. And then later, when you run your tests, that test will always be there and until you take it away. So that's awesome. The other condition is sometimes automated scanners scan for the wrong things, or they scan for slightly the wrong things. And they don't necessarily have the ability to extend. And so you might actually write a unit test case to test for some very specific kind of cross-site scripting vulnerability in your application to make sure that it doesn't show up again if it comes up again. And so, so you've got these special cases that are very specific to your application that automated scanners don't catch, or you have these logic issues that I was just mentioning. So when to use it? Actually, when you use it, it's up to you. When you see these two conditions, that would be a good point. The advantages are you don't get any false positives. And as your application matures, your security tests are not lost. The disadvantages is that you actually have to write those test cases and build them into your unit testing software. And you actually have to maintain them. So if for some reason the application changes such that your unit test has to change, you actually have to do that work too. So it's a balancing act. So you'll need to figure out whether or not you want to do it. Interestingly, the BSIM, so looking at the different organizations that have implemented this, only about 16% of the organizations that were interviewed have this as a regular part of their software security process. So if you're not doing self-made security unit tests right now, it's okay. Actually, this is more of a mature kind of approach to software security. If I were you, I would start with automated testing first and then move into this. Although if you're really gung-ho and you're really good, go for the self-made unit tests, not a problem. So we're getting close to the end of the tools. Security linters. So security linters are kind of a SAST tool. They are lightweight security checkers that you can often build into your own IDE. What's nice about that is you can build it into your own IDE and you get the feedback right away. Now, it doesn't necessarily mean that you have like, when you type things in, it flags a vulnerability right away. Sometimes you actually have to trigger the process in your IDE once you've put in some code. Yeah, but that's how it is. But usually the feedback is very fast, which is very nice. And you have it right there in your IDE before you commit the code. And that's the dream. The advantage, it can be integrated early in the development process. The disadvantage is it's not as thorough as the kind of SAST scanner that you would get if you would do a full build. So the SAST scanners that actually scan at build are much more powerful and do a lot more with the logic of your application to find the vulnerabilities. This will look at the superficial things and give you instant feedback. But still, this will look at the superficial things, give you instant feedback. You can fix them before you commit, and then you have fewer things that you have to resolve later when your SAST scanner does the full scan. And then once again, I've linked to another list, OWASP list. It's actually the same list as the SAST list. So they don't necessarily make a distinction between SAST and security linters. Interestingly, a lot of the security linters are open source and a lot of the SAST tools are proprietary. So that may also factor into whether or not you're interested in pursuing SAST as opposed to security linters when you're first getting into software security. And this wasn't actually in my original slide, but I want to give it a special mention. So if you're a software engineer and you also do operations style things, so if you're in a DevOps environment where everybody's working together and you have both operations responsibility and also software security or software engineering responsibility, you're going to want to have two things that are going to be in your back pocket that can help you. So first is container scanning, and the other one is cloud configuration. So if you're working with containers, so Kubernetes containers or Docker containers, there are scanners that are out there that will help you look for publicly known vulnerabilities in the operating systems in your containers, the third-party components in your containers. It'll do the scan and then report those back to you so that you can actually fix those things before you push or, pull your image into real life, into production. So this space is changing very quickly and maturing very quickly. And it's really hard to find the definitive list that tells you which scanners are the best, just because it is changing so rapidly. So this is what I would recommend to you. If you're interested in this kind of scanning, and you are in the cloud. If you're in AWS or if you're in Azure or GCP or look to see what they offer. Because I can almost guarantee you they will have their own cloud native version of a scanner. And it might be the easiest way to get set up. The next, I've put a little link here to a blog that actually has both Kubernetes and Docker scanners. If you're interested in looking at those, go for it. The next is cloud configuration monitoring. So we all make mistakes when doing configuration in the cloud. Cloud is a very complicated place with many different policies and service accounts and permissions and so on and so forth. And the cloud providers have realized that this is a real problem. And so they've created these really cool tools that allow you to scan basically your entire configuration for your cloud accounts and figure out where you've configured things weakly. And so examples of this are AWS Config, Azure Security Center, and GCP Cloud Security Command Center. These all have components that do scanning for weak configurations, and they make recommendations on what you need to do to fix those configurations so that an attacker can't take advantage of a weak configuration. I find these super useful. And if you didn't know about them and you do now, go look at them because they're really cool. Some of them allow you to actually extend for your own policies. So if you have a check that you would like to do across your account for a specific type of mistake, especially if you're working in a collaborative environment and there are multiple people touching things, you can set up a rule and say, please check for this, and it will do it across the board for you and flag that kind of thing for you. So you do have the ability to extend. Not in all, you'll have to check and see what the possibility is within your cloud environment, but check it out. It's a super powerful tool to have in your back pockets. Whew. So those were the tools. I'm going to take a second here. I've just given you a lot of things. And it can be overwhelming. And for that reason, if you're new to this, I wouldn't recommend going alone. Find somebody to do it with you. It makes it a lot easier and it's more powerful. And I'll talk about why in just a minute. Your first search for allies should be in your software security group. If you came to them and said, I want to try this blah, blah tool, they would be like, whoa, they would be so off the charts excited. Danger there is they might try to give you more tools. Yeah, but we'll talk about that in a little bit. They would be your first stop. They know the most about security and they'll learn more from you actually than you will learn from them when trying to make this tool work, whatever tool you've picked out. But yeah, it'll be a win-win for both sides. But they are great. And let's move on to the next one. If you don't want to wait for your software security group and you just want to get started and you want to find some allies, actually, the state of DevOps has an interesting thing to say about that. When having high performing organizations that are moving forward and moving forward well, what they do is actually they have, rather than top down, you must do this from a software security group, they actually have communities of practice and bottom up grassroots movements as the foundation for why things work in those DevOps environments. And it shouldn't be any different for security. So if you want to start a grassroots movement in your organization for software security, do it. I totally encourage you to do it. It is an awesome growth opportunity. And if you're successful, you're going to be showing a certain type of leadership to your organization, which is sellable. It is good for promotion. And just in general, you're going to figure out that you really like security and you're going to want to come over to the dark side with me in the security group. But yeah, but we're going to start here where we're going to start a grassroots movement. So who do you get involved? Who do you recruit? First, think horizontally. So who are the people like you? Are Are you a front-end developer? Do you do microservices, API? Who are the people who code in the same language as you, who use the same framework? Try to find these people because they're going to have the same kinds of problems, the same kinds of security problems as you. And so you all will be able to figure out the stuff together, which is awesome. It's really great to build knowledge in a community and figure out how to do things and then share that with people. It's a lot faster, you get more done, and it's more fun. Then I would encourage you to think vertically. So are you a microservices software engineer? If you are, you have web front-end people who are relying on you. You might have some sort of database backend that you rely on. You might look at those different layers and get those people involved too, because there are going to be security problems that cross boundaries. And so if you can figure out how to solve those problems vertically, you're going to have a big win for the organization. And if you do it with the groups that you have touch points with, it makes it even stronger. Once you've solved the problems, then start actually documenting what you've done so that other people can benefit from it. In the state of DevOps, once again, they call this internal search, and it allows software engineers and also operations engineers to actually figure out what other people have done and actually use it in their life. And then they don't have to go to Google and have to futz through all of the trash that's out there to find the golden nugget. They can just use what you've done. Better yet, check it into Git, and then people can actually clone it and use it in their environment, and that's the best. And last but not least, when you're looking for allies, you don't necessarily need to look in-house. You can look outside. So OWASP has chapters in all major cities, and they are the super most friendliest software and security people out there. I know because I participate in the one in Munich. Also, look at meetup.com and see if there are any security groups in your area. A lot of times they'll have software security evenings where somebody comes and does some sort of training, or you can do a capture the flag where you learn how to attack things and learn how an attacker thinks. I've actually done these trainings and I've hosted these kinds of CTF evenings where I've targeted specifically software engineers, and working with them is amazing because once they figure out how to attack, they're just like, okay, how do I defend? And it's the most fun. So if you want to learn how to attack and learn how an attacker thinks, look at these local meetups because it's great fun. And the software security people and the security people are nice. All right, we're almost there. So I just have a couple of practical tips for you. So you've learned language. You've learned about tools, and then you've learned about getting some allies, gotten some tips about that. Let's take a step back. I know you want to get started. I know you want to dive in head first, but pace yourself. Let the data guide you. Don't try to take everything and do it all at one time. What you want to do is get information so that you can target your work. So if you look at the state of DevOps, they said, or when they say, okay, for the recommendations that we're making, don't try to do it all at once. Pick 3 to 5 of these problems and actually just focus. Fix these problems and do it well. And I would say the same thing about security issues. So go to your incident response team, go to your bug bounty team, figure out what are the top 5 things that are problematic that they continuously see. They're going to tell you, and then you can actually go and see, am I contributing to the problem? And if you are, fix those things first, and then go to the next thing. But really focus in and fix. Don't try to do everything at one time. Do something small, give value to the business, do it well. If you have neither a bug bounty team nor an incident response team, or they don't provide the information you need, go back to OWASP. In the beginning, I talked about the OWASP top 10. It is there, and number one is the most commonly exploited vulnerability. Number two is the second most. Start there, work your way down. Don't do it all at one time. Pace yourself. If you're going to choose a tool, don't do all of the tools at one time. Once again, pace yourself. Pick one thing, do it well. If you look at the BSIM report, it talks about maturity of organizations, and generally organizations mature as they pick one thing, they go into depth with it, they figure out how to use it efficiently and effectively in the development pipeline, and they make it work, and they really get value out of it. And that's what you need to do. Don't try to take in everything at once. Pace yourself. And find the time. So some of you have 80-20. Maybe this is, so 80% work time, 20% you get to do what you want. Take that 20% dedicated to security. As I said, this is a development opportunity for you, which will make you stronger, both as a candidate for new jobs, for promotion, and for perceived leadership within the organization. Maybe you suggest a hygiene sprint as part of your development process, a sprint that's focused just on security hygiene. Get your whole team involved. That would be great. Maybe you focus on it as a professional development exercise. So the next time you have the opportunity for professional development, you go and you do security training as opposed to XYZ framework training. Maybe you sneak in some JIRA issues and then try to get those prioritized by your product owner or your engineering manager. You'd be surprised, it might just work. Or if you find yourself with something suddenly with an afternoon where you've completed all of your tasks and you've got nothing to do, maybe check out the OWASP site and see what they have there. And as Shia says, just do it. So if you've made it this far, thank you.